Should we go to Venus instead of Mars? For centuries, Mars has held a tight grip on us. In many ways, the red planet isn't so different from ours. We have deserts, polar ice caps, and rocky mountains. It's so similar that we can film movies in places like Jordan or Utah to depict the red planet, and none is the wiser. Mars truly seems like an attainable location for a human settlement. However, Mars might turn out to be one of the worst long-term decisions we make, which is why some people are starting to suggest redirecting those efforts and pointing them toward Venus. My name's actually Christine, and here's how it works. The challenges with Mars are often overlooked in the media and entertainment. Most people think it's the distance and lack of oxygen that makes setting up a base there so difficult. But it has far greater threats. The lack of a global magnetic field is one of the biggest. Without it, astronauts will be blasted with radiation. There is also the issue of its thin atmosphere, lack of resources, and distance from Earth, just to name a few. Venus, on the other hand, has a lot of what Mars can't offer. While it doesn't have a global magnetic field, it does have an induced magnetic field. Venus also has a dynamic atmosphere and is half the distance of Mars. So if anything does go wrong, it will only take us half the time to get there. Venus is by no means an easy choice. It's hot, windy, it rains acid. At first glance, the hellish planet doesn't seem attainable at all, but as a long-term effort, it may be the most suited for a base of operations. So what makes Venus so special? Named after the Roman goddess of love, Venus is the third brightest object in the sky after only the sun and moon. Its thick atmosphere makes it quite reflective, but it's also the closest planet to us depending on where it is in its orbit. We have always been able to see it. Unlike Neptune or the moons of Saturn, Venus has no discovery date. It's just always been there. In terms of size, mass, and composition, there is no other planet in the solar system quite so similar to ours. Venus is just barely located within the habitable zone. This is a broad term that's undergoing some modification, but basically it means a region around a star that's not too hot or too cold to allow for liquid water to be on the surface. There are, of course, moons like Europa and Enceladus that are way out of the habitable zone, but still have water, because those oceans are protected by 10 miles of ice. But drilling poses its own challenges, so for now, we focus on surfaces we can manage. Shortly after the birth of the solar system, about 4.6 billion years ago, there was a volatile period known as the Late Heavy Bombardment, when asteroids and debris were flying all around and wreaking havoc as the solar system settled into itself. This bombardment period is hypothetical. It may not have been that intense or short-lived, but what we do know is that the early solar system kind of sucked. It would have been way too hot and intense for water or life to survive. It's not until the chaos ended and Earth cooled down a bit that the first life forms appeared here, somewhere around 3.5 billion years ago. It means that geologically speaking, life on Earth began pretty much as soon as it was allowed to. And Venus may have had a similar beginning. Back in the day, the sun wasn't as bright and hot as it is now because it was still a young star, just a growing boy. So even though Venus is closer to the sun, it wouldn't have emitted the same intense rays that it does now, leaving this window of opportunity for a more comfortable climate. Computer models estimate that for up to 2 billion years, Venus may have had a habitable surface and shallow ocean. And by shallow, we're talking an average of 30 to 80 feet or 9 to 25 meters. So not as much as Earth, but something. We don't have the data to confirm when this habitable period ended, if it was even that good in the first place. The range is pretty wide, but some estimates suggest that it ended as recent as 900 million years ago. When I first saw that number, I thought, dinosaurs, because I'm an idiot. But 900 million years ago, there wasn't anything big on Earth yet. Cyanobacteria and early forms of sponges maybe, but it's not like animals were roaming the Earth at the same time multicellular life was beginning on Venus. They could have possibly started life around the same time, and even been in a race on which would develop self-determining flesh suits first. But Venus's glory days ended long before that. The reason it changed is because as the sun matured and its temperature and brightness increased, the oceans would have evaporated and any water vapor or clouds that could have created rain would have been broken apart by the ultraviolet radiation. Carbon dioxide built up in the atmosphere, it trapped more heat, and that trapped even more heat and even more heat, creating a runaway greenhouse effect that gave us the hot planet of hell we know today. That greenhouse effect, by the way, is what could happen to Earth. Not as intense because we don't have as much carbon dioxide, but the process is the same. It's just another reason why we need to study Venus to help us manage our own planet and climate. Now, temperatures there can reach 900 degrees Fahrenheit or 475 degrees Celsius, which is hot enough to melt lead. Its atmosphere is about 90 times thicker than ours, about 1,350 pounds per square inch, which would be like a car on your thumb or swimming 0.6 miles deep. It's also still volcanically active, rains acid, and smells like rotten eggs. Venus is is Earth's evil twin. In the 70s and 80s, the Soviet Union was very interested in Venus. They were the first to send an orbiter and to land on the surface. After a few failed attempts, they sent a spacecraft in 1982 that managed to survive long enough to send images which, quite frankly, are horrifying. After 127 minutes of transmission, the heat and pressure finally destroyed it. To this day, they are the only nation that has managed to land on the surface and transmit images back to Earth from the ground. So planting a base there is out of the question, but that's not where we're looking. 30 miles up, the conditions changed quite dramatically. Venus's atmosphere makes the surface uninhabitable. But if you travel 30 miles up, or about 50 kilometers, the conditions are very different. The winds decrease, temperatures drop to about 86 degrees Fahrenheit or 30 degrees Celsius, which allows for liquid water and for our skin not to melt off. The atmospheric pressure decreases to match that of Earth, meaning astronauts could wear normal-ish thickness of clothes instead of bulky pressurized suits. This would make it much easier to go outside and collect data or conduct repairs. There would also be carbon, hydrogen, oxygen, and nitrogen present, which would be useful for us to make breathable air, fuel, or even nutrients for soil, all of which we can extract from the atmosphere. In terms of energy, we would have no shortage of solar power. A full day on Venus is 243 days. That means 117 days of darkness, but the winds in the upper atmosphere would keep a station moving along, and so it could orbit the planet within a week. Gravity is also about the same, which is great because our bones, muscles, and cardiovascular health greatly depend on gravity. Astronauts on the International Space Station need to work out for 2 hours a day just to maintain the basics. And while that is astronauts in a state of weightlessness, Mars's gravity isn't great, about 38% of Earth's. Meaning, if you weigh 170 pounds or 77 kilograms on Earth, you would only weigh about 65 pounds or 29 kilograms on Mars, so it is very light. On Venus, you wouldn't have to worry about that because gravity is about 90% of Earth's. That takes care of the biological functions, but there is also the issue of radiation. Earth has a global magnetic field due to a molten iron core. This motion of rock and metal creates a magnetism that stretches out and protects the planet from solar and cosmic radiation. We're very lucky to have it. Venus has a molten core, but it doesn't generate the same magnetic field as Earth, which is probably because of its makeup, tectonic plates, and or the way the molten iron is moving. What it does have is an induced magnetic field, which is due to a reaction between Venus's outermost atmosphere and how it interacts with ultraviolet light from the sun, thus inducing a magnetic field. It is weaker than Earth's, but with the addition of Venus's thick atmosphere providing about 1 kilogram per square centimeter of mass shielding from radiation, astronauts will have protection. You might be wondering how people survive blasts of radiation on the ISS, but they are actually still protected from Earth's magnetic field. It's not as strong at that distance, but it is there. Even on the moon, there's still a bit reaching out. So we don't have any long-term studies on what raw solar radiation will do to the human body because we've never sent anyone out that far for that long before. Too long in those conditions could be lethal. A deep space journey through the vacuum of space will be risky. We have spacecraft that can block some radiation, but not all of it, so they will be exposed regardless of which planet they go to. If they go to Mars, they'll be exposed for twice as long. With current technology, a one-way trip is estimated to take 7 to 10 months, and a round trip isn't just doubling that, it's more like 2 to 3 years because of launch windows. Because planets don't orbit the sun all together at the same rate. Sometimes Mars is on the opposite side of the sun, and sometimes it's right next to us. We can't just go there whenever we want. We have to time it just right so that we're not chasing it around the sun. This is a launch window. And in the case of Mars, it opens every 29 months. For Venus, it's about 19 months, and that journey can be done in a few months. All in all, Venus is much quicker and more regular. Landing, of course, is the thing that's held everyone back from seriously pursuing Venus as a base of operations. We can land on hard surfaces. We've been doing that since the Apollo era. We come in at high speeds, and the ground catches us. Even water can stop our fall. And while Venus has the most similar conditions to Earth, hands down, it's only in the upper atmosphere, so the only realistic settlement is one in the clouds. Meaning, we would need to figure out a way to come in hot and stop midair. High risk, high reward. The mechanics behind having nothing to stop our fall is not something we've hashed out quite as thoroughly as landing on a rock. Once we're there, it will be easier, since Venus's atmosphere atmosphere is so dense and has a lot of stuff in it, we'll be able to stay afloat like a balloon with less effort than we would on Earth. In fact, some estimates suggest that a 1.3 mile or 2-kilometer surface could hold up to 6 million tons, which is enough to support the mass of a tiny city. So the next series of spacecraft that arrive can just land onto whatever platform is already built. It's that initial station that will be the hardest to set up. If the technology allows, it might be better to send machines ahead of us to build it, or a parachute where it has some kind of auto-deploy mechanism. Then we just land on it like we would any other surface. But that hasn't been tested yet. It's one of the many reasons why Mars is more appealing at the moment. Its gravity may be lower and its atmospheric density less, which changes the aerodynamics of landing a machine on the surface. But so is the moon, and we plop onto that just fine. Landing on gas will be a different beast. There's also no room for failure. If a station or person falls, the surface is a death sentence. There will need to be many backup safety measures, and no one could step outside without a system in place, like balloons or a new age parachute. In the short term, Mars is certainly more appealing and easier, at least to send machines, but for a long-term settlement, a permanent base for people, Venus is the better investment. It's a tree that is planted under whose shade you will never sit. Convincing nations to invest in a project they will never see the benefits of is a hard sell. One thing that might speed it up is if we detect signs of life. It's unlikely that anything can survive on the surface of Venus. Even we struggle to send machines that can last more than a few hours. It is currently in dispute, but in 2020, scientists at MIT observed what might be signs of life in the clouds: phosphine, a colorless, poisonous gas that smells pretty gross. It's believed that on a rocky planet like Earth, only life forms or our industrial use can create phosphine. Soviet probes also detected particles in Venus's lower atmosphere that were roughly about the same size as a bacterium. All of this could be some kind of floating single-celled organism living in the clouds, or it's just a chemical process that we don't know anything about yet. Either way, we do need more data. As of right now, there are no active spacecraft orbiting Venus. Japan lost communication with their orbiter last year, and the United States hasn't had anything in orbit since the 90s. It's actually kind of alarming how much we don't know about Venus in comparison to how much we know about Mars. Fortunately, India has plans to send an orbiter in the next 2 years. Rocket Lab and MIT plan on sending a probe in the first private mission sometime this summer, and the European Space Agency is planning on sending an orbiter in 5 years. NASA plans on sending an orbiter as well, but another goal of theirs is to send a probe to the surface to collect high-resolution images, which would be awesome. Basically, there's a quiet race to Venus, and everyone seems to want to get there in 5 years. With this inflow of new data, we might be able to determine what the Soviets detected and see if there is indeed some kind of form of life. We could get accurate readings of the landscape and a better understanding of the many layers of Venus's atmosphere. But most importantly, we could determine how feasible it might be to build a station and experience life in the clouds.